Hi everyone, this is Mr. Rob and we are going to do today vector addition the analytical way. So let's begin. First we need to have the problem, and I'm going to draw it here. I'm going to draw this box, and from here there's going to be one guy pulling this box and the other one here. Now that seems strange, but if you put a reference here in the center, you will see that you will have 60 degrees here, and you will have on this one over here 45 degrees. Very simple. And the real thing we want is we want to know if these two vectors, like what is going to be the resultant force, or where is it going to move really with the addition of these two vectors. So we're gonna add them up. Basically what we need to do is get where we need the force that we will be dealing with. Let's see, 200 newtons on this one and 120 newtons on this one. Okay, so let's start this up, and what we will need to do is very simple. We'll build a chart, like in for example, we can just do this in X, meaning that we will get this number 1, number 2, let's call it like that, and we will be having all the additions in X. So how will we do it? And it's very simple. We know that if we take the angle from the x-axis and up, or the x-axis and down, we will end up with the cosine for x and the sine for y. So here we go. We have 200 cosine of 60. That's for 1, right? That is the component of this one. It will be this one here, the component here. Now the component in X, whoops, air conditioning, for 2, same thing. We will have 120. This will be it. So it will be 120 cosine of 45 degrees. That's it. Simple. Now in Y, for the first vector, we will have 200 sine of 60 degrees, and on this one 120 sine of 45 degrees. Oh, that's it. Okay, mostly it's it. Now we need to know, for example, what's the value of this one, and I'm going to write it here. So I'm going to repeat the same 1, 2, but now I'm going to get the results that I got. Okay, so for the first one, the 200 cosine of 60, I will get 100 here. And for the next one, the second vector is going to be negative 45. You can put negative 45 here, negative 45 on both, same thing. You will end up with basically, and then it will be important for you to put it there, or just you need to know where they go. For example, this is going to be the y one, and this one is going to be positive. Do you see? It's going to be 1y. The one here, 2y, is going to be negative. Either you put it or you just know where it goes. If you want to get the sine, or the sine of this, I suggest you use the total. So if you don't want to deal with this sines, I suggest you use the total angle. This one basically will be, instead of that one, you will get the same result as in 360, which is the whole turn, minus 45 degrees, and you will get the same. This will be equal to, and if you do the addition, you will have 45 to 60 you need 5 to 50 and 10, so it's going to be 15 degrees. So 5 more is 20, and 40, 60. So that this is it. You can either use that. I suggest you use this instead of negative 45, right? And well, that's basically it. Now let's see. For this vector over here, we have 84.85. That's for x, right? And for this one, we will get 173.21. What will be this? Newtons, of course. Newtons. And for this one, negative. And the negative, again, this sign comes either from this, putting that angle, it will automatically will be given to us, or basically with the other sign. I suggest you use this one again. Here we will have 84, if I'm not mistaken, 84, negative 84.85. Why this? Because this 45, you have the same in x and in y. That's why we have that. So what we do next is we add this to, we will have like the sum. That sign is the sum, is sigma, capital sigma in the Greek alphabet, and we will have 184.85 newtons in x, right? In x, plus the addition of these two, which will be 88, if I'm not mistaken, 88.36. Let me see. Yes, 88. We're gonna add this up. 88.36 newtons. So now we know that we have this two components. So basically, this can be translated into this. We have positive x, so we have here 184.85, and in y we have positive 88. It will be if this is it will be around there, 88.36, right? So we will end up with this resultant. Now how or what would be the resultant force? Very simple. We just do Pythagoras, because we have this side and this side, so we have, this is 88.36, so we have both sides, right? And if we have both sides, we can do Pythagoras. So r, let's call r the resultant, is going to be equal to the square root of 184.85 to the square plus 88.36 squared, and this calculation will lead us to 204.88 newtons. So this is going to be the magnitude of the sum, the addition of these two vectors, and it will be in that direction. Now, what direction will that be? What angle shall we have? Well, we have the inverse tangent of y over x, meaning the inverse tangent of y, which is 88, is this one over here, 0.36 over 184.85, yes, and our angle is going to be 25.5 degrees. So basically that is our angle. How can I find where is my angle? Well, okay, it starts from the axis and is the one that will be on the quadrant of our resultant. So these are results also. And there are some ways if you see that the angle will be here, this will be the resultant force, and how can we be sure that is true? Well, basically we can check this in different ways, but we're almost certain that this is like this. So this is example 1 of the addition of vectors. Thank you very much. See you on the next video. Bye bye. I say bye bye. Ciao.